All right, hi y'all, this is Mr. Labonte. I'm going to review some of the concepts on the periodic table, and I'm going to do that by just talking about this image of the periodic table. So again, the periodic table is organized so that the rows here represent the valence electrons. So these first two elements can take two valence electrons. That's why there are only two there. In the second row, there are 8 elements because there can be 8 valence electrons. Similarly, in the third row, there are 8 elements, so there can be 8 valence electrons. So the organization of the periodic table is talking about valence electrons. Here in the periodic table, for instance, if you have helium, you have 2 protons and 2 electrons, so the charge of these elements is 0. But that doesn't necessarily mean they're stable. There is a set of stable elements. These are called the noble gases, and these are the elements right here that I'm highlighting in red. So these are the stable elements because they have their valence shells filled. The other ones do not, and we'll take another careful look at this, and we'll talk about the difference between ionic and covalent bonds in this discussion. So we'll start here with the first element. So this is hydrogen here. You can tell it's hydrogen because it has 1 electron. Here the protons aren't listed, but this is 1 proton, 1 electron. So in this case, the hydrogen is sad. The hydrogen would like either 0 electrons or 2 electrons. So we would call it unstable. The next element that we're going to be looking at is helium. And we can see that there are 2 electrons here, and this would be 2 protons. So this would be stable. This would be the stable configuration, the first valence electrons shell, which is 2 electrons. Then as you move along the periodic table, you're going to go down and to the left, and you're going to see lithium. Lithium has 3 electrons, 1, 2, 3. And you'll see this one here is in the next valence shell. So after you fill the first valence shell with 2, you go to the next valence shell, and there are 8 possible electrons there, though it only has 1 of the 8. So what lithium would like to do is it would like to get rid of the extra electron that it has, because the option of gaining 7 additional electrons really is a poor option. So its goal would be to get rid of that electron. That's going to make it positive because it's still going to have 3 protons, but in this case it would only have 2 electrons. So that would give it a charge of positive 1. So when you see lithium, you are going to see it as a cation. So lithium is going to form ionic bonds for that reason. Now as we move along, we're going to go all the way over here to carbon. Carbon, as you can see, has 1, 2, 3, 4 electrons in its valence shell, yet it would like to have 8, just like all of the other elements in that row. So it would need to get an additional 4 electrons. That is not going to happen because every time you add an electron to carbon, it's going to become more negative. Alternately, it could get rid of its 4 electrons. Again, that is not going to happen. So because carbon doesn't have either of those 2 options, the option that's most available to carbon is to share electrons. For example, carbon might bond with another atom, another element, like hydrogen. So that would be a bond, and we would represent that by drawing a line between the 2, which signifies that there's 2 electrons. And carbon could do that with 4 hydrogens, fulfilling its octet because it would be able to use 1 electron from each of the hydrogens. And then we would note that as CH4, which happens to be methane. So that's the example I used in class. Similarly, so now we're going to go back, we're going to look at nitrogen, 1, 2, 3, 4, 5, 6. Sorry, this is oxygen. I didn't include nitrogen, so that's 6. So this is oxygen because it is 8 protons and 8 electrons. Remember, 6 and then 7, 8. You have the other 2 electrons there. Oxygen can fill its octet by taking on 2 additional electrons, but oxygen will almost never do that to become an anion, because it would be negative. The way that oxygen will do that most often is by bonding. Here's an example where oxygen bonds with two hydrogens, and that would make it H2O because the subscript is the number. These again are covalent bonds. Another potential option for oxygen, and I'll erase this and add it here, might be for oxygen to bond with another oxygen. If that was the case, and I'm not going to draw, well, I'll draw it. If that was the case, you'd have, that's the nucleus right there. You'd have the first valence shell with 2 electrons there. Draw them a little bit larger. And then the second valence shell with 1, 2, 3, 4, 5, 6 electrons. And then if oxygen were going to form bonds, it would form a bond between those two and those two, giving 8 to each, and then that would be O2. So that's that molecule. Finally, we're going to move over to the right side of the periodic table. So this is fluorine. 2 in the middle, 3, 4, 5, 6, 7, 8, 9 electrons here, and it needs just 1 more electron in order to become stable. So fluorine, rather than forming a covalent bond, will form an ionic bond because it will take an electron from something. That's what will make fluorine stable and give it a stable inner octet and a stable outer octet, 2, 8. But it will also give fluorine a negative charge. So when you see fluorine, you will see it most often as an anion with a negative charge. And all of these elements are trying to reach this configuration, which is 2 on the inner shell and 8 on the outer shell. These are the noble gases, and this is neon. So I hope that this was helpful for you. The only other thing that I would say here, actually kind of an important thing, at the end, we have a name for these. When you form these ionic bonds, like sodium chloride, right, or lithium fluoride or something like that, these are called inorganic ionic bonds. And then if you have formed bonds that have carbon in them, these are called organic. You may have heard of organic as having to do with life, right? And so since carbon is the basis of life, that's organic, and we'll review that in class.